Okay, in this video we're going to have a look at the reaction of group 1 metals, the alkali metals. Just start off here with the general equation. So the metal reacts with water to make a metal hydroxide and hydrogen. And we're going to have a look at how we identify these two products during the reaction. The first thing we notice about the way these react is when we drop them into the water, they float on the surface, and that means they have a low density. When they're on the surface of the water, you'll notice it start to whiz around and move around the surface as it reacts. It fizzes. This means it's making a gas, and the chemistry word for that is effervescence. So it produces a gas, effervesces. We normally put indicator into the water that it's reacting in, and that indicator starts off green because water is neutral, but then during the course of reaction, as we start to make more of the metal hydroxide, because this is going to be an alkali, the indicator starts to turn purple to show that the alkali is being produced. The gas, so the hydrogen here, we can collect it, and we can carry out the pop test, so a lighted splint goes into the gas and it burns with a squeaky pop to show that the gas is hydrogen. And then what I've got at the bottom here for you, just to illustrate all this, is a real example. So there's lithium, a group 1 metal, reacting with water, producing lithium hydroxide and hydrogen. In terms of turning this into a balanced chemical equation, so lithium and H2O. Lithium hydroxide is LiOH. If you're unsure why, watch the video on forming chemical formula. And hydrogen is diatomic, so it's H2. Okay, you then need to balance this reaction in order to make it work. So here, what I'm going to do is put a 2 there to give me 2 lots of hydrogen, and 2 there is 4. Therefore, I need 2 there to get me 4 lots, 2 oxygens, 2 oxygens. I've got 2 lithiums here. Therefore, I need a 2 there, and now I have a balanced chemical equation for this reaction. If you're unsure how to balance, watch the video on balancing equations. And all we do here is we swap sodium or potassium into here, and this reaction then stays the same for each of those metals.